to this new episode of the Food Systems Talk. My name is Elisabeth Türk. I'm the Director of Economic Cooperation and Trade at UNECE. UNECE, that's the United Nations Economic Commission for Europe. And today, I'm also your moderator for the Food Systems Talk. And the Food Systems Talk is an initiative launched by the Issue-Based Coalition for Sustainable Food Systems. So what are we trying to do with today's Food Systems Talk? I think we are trying to achieve three main things. First of all, to get an understanding of the circular economy and of some of the paradigms and conceptual frameworks behind it. Secondly, to see how these paradigms and conceptual frameworks that make up the circular economy, how they can help us transform our current food systems. And thirdly, we want to look at some very specific examples. So for the examples, we go to Europe and to Central Asia. That's the region covered by UNECE. But for the examples, we are also going to look at you, consumers, because ultimately it's all of us as consumers who matter for food systems. So most importantly, also, we want to give you food for thought to think about how the circular economy is important for all of us, including for what we eat. Now, if we take a step back, we see that our current linear food system is really failing us. Our linear food system is the primary driver of biodiversity loss. Huge problem today in the context of the planetary triple crisis. Our current linear food system is also accounting for a third of greenhouse gas emissions. So huge contribution to climate change. And all of that at a time when still in 2030 or 2023 today, many people are still suffering from hunger. And they suffer from hunger at a point in time when also almost 1/3 of food is being wasted. So what if there is a better way? That's the question we are trying to respond to today. And for that, we have a very special guest. We have with us here today, and we are very pleased to welcome a real expert, one of the first ones who did some conceptual thinking on the issue of circular economy and food systems. So it's my great pleasure to welcome here with us today, Professor Dr. Martin van Ittersum. And Professor Dr. Martin van Ittersum is from the Department of Plant Sciences and Plant Production Systems Group of the Wageningen University. So, Professor, many thanks for joining us today and for engaging in this discussion on how to make food systems more circular.
Martin van Ittersum holds a PhD in agricultural and environmental science from Wageningen University. He is a professor at the Plant Production Systems Group of the same university. His research and teaching focus on research concepts and methods for the analysis, design, and integrated assessment of agricultural systems from field to farm at regional and global level. He has led and is leading a large number of national and international projects dealing with global food availability, integrated assessment of agricultural systems, yield gap analysis, phosphorus scarcity, climate change, and circular food systems. He was the co-chair of the first and fourth editions of the International Conference on Global Food Security, and will be the chair of the fifth edition, 2024, in Leuven, Belgium. In 2015 and 2016, he was the interim chair of the Farming Systems Ecology Group at Wageningen University. Since September 2022, he is visiting professor of the Swedish University of Agricultural Sciences. He has been nominated a highly cited researcher from 2015 to 2022 and has authored and co-authored around 200 papers in international scientific journals.
Now, Professor, you are professor at Plant Science, Plant Production System Group, and your expertise is in integrated assessments of agricultural systems, in yield gap analysis, issues such as phosphorus scarcity, climate change, and circular food systems. And if I understand correctly, in 2018, you were among the first ones to introduce a conceptual framework for circularity in the food system. If I'm correct, that was a booklet you wrote with a colleague of yours, that's Professor Imke de Boer, on circularity in agricultural production for the Mansholt lecture, I think. So let us start with this, and maybe you can tell us a little bit more about the work of your department and the work of Wageningen University on circular food systems. Over to you.
Yeah, I'm happy to do that. Yeah, so I'm a professor in plant production systems. And that means that we look at plant production from a systems perspective. So not so much the details of single crops, but how crops are grown in a farm, in a region to produce enough food and in a clean manner and with good quality and of course also accounting for economics. And importantly, also the collaboration or the interaction with animal production, because of course that's another important part of our agriculture and food systems. So that also explains that I prepared this Mansholt lecture together with my colleague Imke de Boer, who is professor in animal production systems, so plant production systems, animal production systems. Let me explain a little bit more about what I'm doing, what we are doing in the plant production systems group. It's not only circularity and circular food systems. It's, let's say, to look at crop production, plant production from a systems perspective, and to see what are the important challenges with respect to the future. And then, I mean, I think it's very important to always recognize that different regions have different main challenges. In Europe, we have challenges, but if you look at Africa, South Asia, it's totally different. The demand for food there will increase a lot, and producing more, probably mostly on existing land, is number one priority there. But here in Europe, the population is stabilizing, maybe even slightly decreasing. We are aging on an average. We already eat too much animal-based proteins. So I think here the demand for food will not increase, maybe rather decrease. And I think we are rather differently from Africa and South Asia. We are in the position in Europe and some other parts in the world as well to focus on the environmental aspects of food production. And here circularity can be very interesting. So that is one of my now main themes in research. The other one is how can we produce more in Africa on the same area and in an environmentally responsible manner. But for Europe, I think circularity is a very relevant topic. And yeah, I'm happy to tell you more about what that means.
Great, you're really dealing with a very fascinating topic. And, you know, when you said we have to take a regional approach, I think that's also really at the core of the UN, where we are dealing with very different regions. And you already flagged sort of some of the fundamental differences between Africa and the European or pan-European region. Yeah. So let me ask you now, you mentioned circular economy already, and circular agriculture, if I understand correctly, is based on the principle of optimizing the use of biomass. So waste streams from one supply chain, they should be becoming raw materials of another supply chain. And I guess that really requires rethinking food systems. And I would assume that also requires sort of like integrating a little bit the plant-based and the animal-based supply chains. And you already kind of like mentioned those two tracks in your introductory statement before. So let me ask you, what is needed to make food systems more circular? And I mean, how should we go about thinking about what is grown, what's the role of agricultural byproducts, and what's the use of farm animals in such a system?
Yeah. Very good questions. So you already mentioned in your introduction the Mansholt lecture that we gave in 2018. And for that occasion, we actually came up with 3 key principles for circular food systems, if you want. And I can briefly summarize these 3 principles, and we can then discuss each of them in a bit more detail to have an understanding what they mean. But first, in summary, so the first one is actually use the good land, let's say the good land in terms of soils and climate, to produce biomass, first of all, for human consumption, and not so much to feed animals or maybe to produce energy or other things, but the first priority is to produce good food for human beings. And that implies that, I mean, at the moment we're using maybe almost 40% of our cereal production to feed to animals, which of course in itself, that's not a very efficient process, because the animals will, in fact, not, I mean, if we have 40% of the cereals that we use as feed, we will lose a lot of weight in terms of final products, milk and meat, when it comes to the consumers. So the efficiency losses through the livestock production, that's not a very good thing. So use the land, first of all, the good land for to produce biomass for human consumption. Now, there's more things behind it. I can explain that later. Second principle is the byproducts, the co-products. First of all, let's try to avoid waste products and losses as much as possible. But several byproducts and if you want, waste is unavoidable. And then we should reuse these byproducts in a good priority for the right purposes. And I want to come back to that later. That's the second principle. So avoid losses and waste as much as possible, but there are unavoidable products and byproducts. Then it's important to reuse these in a good manner and with the right priority. The third principle is the role of livestock, the role of animals. Rather than feeding them with products that we could also consume directly as human beings, like the cereals I mentioned before, I think we can use the animals in what they're good at, and that is upgrading stuff, biomass, that we as humans cannot eat, like straw, like grass, like byproducts that come with the industry when we make French fries or sugar or whatever, or beer, and the animals, they can eat those byproducts and produce fantastic products like the cheese that at least I love a lot, the milk or the meat, and etc. And in that way upgrade biomass, which is of less value to human beings. So those are the three key principles that we defined for circular food system, circular agriculture, if you want.
Great. So very clear. You said like using the good land to produce the food that humans eat. Yeah. Looking at the byproducts, avoiding them, but also using them. And then thirdly, the role of animals and thinking about what animals could eat so that they that we kind of like are as efficient here. Fascinating. So these, I guess, are some ways about how the current production systems could be transformed into more circular modes. Now, in all of this, I guess there's always like a really strong connection between science and academia on the one hand, and Professor, we are super happy to have you with us in this regard today, and policy development. So tell us a little bit on this front. How do you believe that the policies and incentives, what role can they play in terms of promoting circular economy in food systems?
Yeah, that's a big question, and I think there are small things which can be rather easily stimulated, and that's usually in terms of, first of all, awareness. I think that byproducts are valuable products, that there is nutrients in it. Take manure from livestock, where nutrients, of course, in it, and there's carbon in it. There are byproducts that you can use as feed for livestock. So creating the awareness that there is value in these products and that they can serve different purposes. I think that is something that through policies that stimulate awareness, let's say communication, education, that can already make a difference. But if we talk about the bigger changes, so using our land not so much to produce feed, but to produce food crops for our humans consumption directly, of course, then economy comes into the picture, and prices and what is most rewarding for farmers to do. And that requires much more systemic changes in our economy, including probably also what we as consumers do and change our consumption behavior. And maybe have to pay different prices for products. So there are small things like recycling byproducts, etc. And another example of that could be maybe trying to process our waste, which ends up in cities, like the sewage sludge, etc. Investing technologies that really take out the valuable things in that waste, if you want, the nutrients that can be reused as fertilizer for agriculture. That's probably relatively small steps that can be done. The bigger things, using our land differently to grow different things, and consuming differently as consumers, those require, of course, much more major efforts from policy, and there's also a longer term effort probably.
Yeah, you raised some of the very big questions and issues here, and I guess like raising awareness. I'm hoping that also today's podcast and recording will contribute to that. But you rightly said so. I mean, we have all the economic questions: how to stimulate the right demand, how to stimulate the right production. And Professor, I'm very happy that you also mentioned the role of technology and innovation, because I think here policies can also really shape countries' innovation system so that we find these new solutions towards making our food systems more circular. Now, we've already talked a little bit about circular economy approach and frameworks. And I guess that our audience would be really interested in knowing a little bit more, some concrete applications on the ground, so that also our countries in the regions can learn more. And I'd like to ask you here, maybe you can give us some examples of good practices in terms of circular economy being applied in food systems, some sort of like win-win solutions where we found examples where environmental, social, and economic factors come in and play together in a mutually supportive way.
Yeah. Well, I mean, in general, I think when it comes to farming, it often comes with, let's say, a collaboration between crop producers and livestock producers. It's not that we advocate, let's say, mixed farms, that the farms of the future have crops and also have animals on one and the same farm. But in a region, there can be a collaboration between specialized crop farmers and specialized livestock farmers. And these farmers can exchange feed, and the crop farmer can exchange maybe residues or fodder products that can be used by the livestock farmer. And the livestock farmers may have manure, which is valuable to the crop farmers. That's a very simple, basic example. We're actually, I'm running a project with colleagues from Denmark and France and Scotland. And we were together a few months ago in the south of France. And so a beautiful example is a crop farmer who produces maize for seed. And so the seed is harvested to sow for a next crop in the next year. And for this, because it's hybrid seed, it's important that the male plants are harvested at some stage. And that the female plants can bring the seed to maturity. So the male plants are harvested immature, and that is biomass, which is actually not very useful, functional for the farmer. That's not the purpose of his crop. But that biomass goes to a cooperative biogas plant where the male plants are processed, if you like, and biogas is produced there, and the digestate with the valuable nutrients in it is returned to the crop farmer as a fertilizer. So the male plants are used to produce energy and to produce a fertilizer, which if you want, you could use it. You could call it an organic fertilizer. So that the farmer can use that then to fertilize his next crop. Now, the third player in this collaboration is a livestock farmer who lives a bit further away, closer to the Pyrenees, and who has a lack of feed in the winter. And he brings his sheep to the crop farmer. It's about 40 kilometers distance. And the sheep is grazing the cover crops that are grown by the crop farmer in the winter to protect his soil, to keep his and to catch nutrients which otherwise would leach away, and to keep the land green during wintertime. And the sheep is grazing that, and is of course putting the manure also on that cropland. So I found that, and that's a win-win, of course, for the livestock farmer, because he has feed for his sheep, and he doesn't have that on his own farm. And the crop farmer doesn't have to mow or to kill as much biomass as he would have without the sheep, and he's also getting fertilizers from the sheep. So I think the crop farmer, the biogas plant, which is a cooperative, so it's owned basically by the farmers, and the livestock farmer, the sheep farmer, they form a perfect collaboration where the biomass and residue products are floating around and brought to value, if you like.
Great example. So maize, sheep, and biogas, and as you mentioned, they don't necessarily have to be in one farm, but it's really about like combining them in a region and creating the synergies. So we also did that field trip to southern France, and I was stunned also about this like sequential harvesting that plays a key role in terms of the different plants here. Now, moving on from the farm, let's move to us as consumers, and let's talk a little bit like food waste. We know that 1/3 of the food production is lost or wasted, and that plays sort of like a crucial role for advancing the circular economy in the food systems to if you also want to kind of like mitigate climate change and mitigate both mitigation and adaptation strategies. So if we look at that, to which degree can climate and resource efficiency goals be achieved in food sectors through circular food systems or circular strategies? And what's really the importance of food loss and waste reduction, and also maybe reuse in achieving climate and resource efficiency goals?
Yeah. Thank you. I think, first of all, it's important to avoid the waste where this is possible, and the losses as well. And that is, I mean, that's usually in our Western societies in the production chain. So after the farm gate and in the shops and with the consumers. If you come to lower income countries, then usually there's also a lot of loss on the farm and in storage, etc. But avoiding losses and waste, that's the #1 priority, because that means that actually more ends up on the plate of the consumer, which is always more efficient than having to reuse or recycle the products. But then secondly, some losses, waste is unavoidable, and then it can be very efficient to reuse that. Either as a way to maintain the soil quality, to keep your soil healthy and fertile for the next years. I think that should always have the first priority, to keep your soils healthy and fertile, because that's basically this resource base for our food production and for the farmers. So it's in our interest to keep that in good quality. But other destinies could be to use the waste and the byproducts for feed, or or to produce fertilizers. It can be organic fertilizers, can be through the digestate, can be also more in mineral form. And even we could consider to use it to increase carbon content in our soils to offset greenhouse gas emissions. Now, personally, I'm a little bit less optimistic about that last option. I would favor to use it for the first priorities that I mentioned: soil quality, feed, or produce energy and fertilizers. I think that's more useful.
Right. So I hear you, like, first priority is always to avoid the loss, yeah. But then there are some very solid ways about how we can use that food waste. And you expressed a little bit of hesitation in terms of the increasing the carbon content, and I guess that's where also future will show how technology evolves and whether that's a viable path forward. But using the food waste to improve the soil and to use it as feeds are very solid options for now. I understand.
Yeah, and you can actually show that, and we did that in studies, that in that way you save resources, because and you can actually show that by using some of these byproducts as feed, you actually save land, and you save, for instance, nutrients, phosphorus, because if these byproducts would normally not be used for human consumption, but now that the animals are eating it and produce milk or cheese or beef or meat, we actually get beautiful food out of these byproducts that would otherwise not be used. And in that way, you save land and you save phosphorus. So it is resource use efficient in that way. Of course, if you only produce animal proteins in that way, there is a limit to it, because there's not an infinite amount of byproducts and biomass that you can use for that purpose. So it will, in the end, lead to a smaller animal production.
Great. You are already transitioning us to the next question, because you keep mentioning food and the French cheese or other cheeses. So let's look a little bit at the role of consumers and also the consumer behavior, because I do believe that sort of like we all as consumers and as in our consumption choices, we can also drive change in promoting a circular economy for food. Now, Professor Edersson, how do you see the role of consumers to promote circular economy of food, and also to enhance sort of sustainable diets and healthy food systems or healthy food choices? Because here all three elements come together. Over to you.
Yeah. Well, first of all, of course, as consumers, we should try to avoid waste and losses. I mean, that's something we can do very practically, and I think there are many examples of this that are already occurring, and that will certainly help. The other example through which we can affect and promote circularity, I think, is to in the end, reduce animal proteins, the consumption of that, and that will also be necessary if we want to consume livestock products in a more circular manner. So with these low opportunity biomass, to use that to feed the livestock, then it means there will be a lower production and a lower consumption that comes with it. So we have to moderate our consumption of livestock, animal-based proteins. So in that way, we can really help to make that transition. Now, that, of course, that's not only coming from the consumers. The entire food system and maybe even the economic system that is related to that will have to make that transition.
So, Professor, we've talked a lot about circularity in food systems like this, but maybe we can deep dive a little bit and think specifically about circularity or circulating nutrients. Can this be done? And can this maybe help us also when we look at the need for fertilizers these days?
Yeah, I think that's a very important aspect of circular agriculture, circular food systems. Take the example of manure that is produced by livestock that contains really beautiful nutrients that can be reused, recycled into the system for cropping or for grass production. But I think it's important to distinguish or discriminate between for instance, what happens with phosphorus and what happens with nitrogen. These are the two main nutrients for plant production, basically, and nitrogen and phosphorus in that order, I would say. Now, for phosphorus, I think there's a lot of promise in recycling it. If we really develop the right technologies, and are very careful with collecting our wastes, products, etc., and reusing them and processing them, we can recycle really much, maybe even 90% of our phosphorus. Also the phosphorus I'm talking about that ends up in the sewage sludge in the cities or in our green waste or wherever. And that can then actually substitute, if we do that well, the let's say the mined phosphate, the rock phosphate, which comes from maybe West Africa or China or United States. There's only a few places on our planet that actually have this rock phosphate. So I think that we can win a lot. For nitrogen, the story is more complicated because nitrogen is a much more volatile element in the system. You lose it in many different ways, as ammonia, as nitrate, as N2O, as a greenhouse gas, etc. So, and it's very difficult to control that those losses. There will always be losses somewhere, and to recycle the nitrogen completely, that's much more of a challenge. So I think there, yeah, definitely we can substitute some artificial fertilizers by recycled nitrogen, but not to the full extent. So here I believe we also need artificial fertilizers, is my strong belief. The only alternative will be a massive extension of the area with legumes. So these are plants that are able to biologically fix the nitrogen from the atmosphere. But of course, that will take also a lot of land. So I think here it's a kind of trade-off also. Do we want more land with legumes, including non-productive legumes, just to fertilize the soil and the land? Or do we keep on using artificial fertilizers? Hopefully, as soon as possible, produce with green energy, not with fossil energy, but with wind or solar energy. And then I really don't see the problem with that, because that actually saves us a lot of land.
Now, it's all been fascinating. We've talked about different regions and we've talked about different policies. We've learned about like crop farming and livestock farming and how to create synergies between them. And we've sort of like looked at how to reduce food waste and the role of consumers, of all of us in this regard. And Professor van Itersum, that leads me to my final question to you. If you would have one takeaway message, what would it be?
Challenging question, and certainly for scientists to be unnuanced and say one thing. There's always several things to mention. What I think important in circular agriculture, circular food systems, is that biomass has always value, and try to give it the highest to give it. And use it with the highest value, I would say. So the way we organize our food system at present by producing too much products which we as humans could consume directly and feeding it instead to animals, I think that's one important thing that hinders an efficient and cleaner food system and a circular food system. And we can make it more circular by reusing the byproducts and use it for the right purposes. And livestock, as livestock feed, can be one important purpose.
Mm-hmm. So really looking at the byproducts and using them for the best purpose, and for example, as livestock feed.
That's yeah, and but I think maybe number one is how how do we produce and use biomass? So always be critical and how do we use our good land? Do we use it to produce food, or do we use it to produce feed or even bioenergy, which is a lower value as a biomass product, and we're using precious land for that. So let's be critical about that. Yeah.
Okay, so very clear key message towards the end, and I guess we will all take that message also home with us, and kind of like have it shape the work we are doing, and kind of inspire us in our different work streams here in the UN and in the issue-based coalition. And Professor Dr. van Ittersum, it's for me now to thank you for sharing all your insights, for sharing exciting stories and best practices and case studies. And I would also like to thank the team from the issue-based coalition to set up this recording, and to thank all of you who have taken the time to be with us today. And I very much look forward to having you with us in the next talk. For that purpose, please do visit the Issue-Based Coalition on Sustainable Food Systems website. There you can find more updates, and you can also find some insights and links into our joint work. And I hope that this will be interesting and inspiring, and that we can see you all at the next Food Systems talk. Thank you very much.
Thank you.